Okay, hey guys, let's just, I'm just gonna create a new lesson. This is just chapter one. Oh, sorry. This is chapter one, two. Um, so, the aim is points, lines, and planes. It's very basic. So let's continue. So in the last video, we defined a point, which was just a location. There was no dimensions. The next thing we talked about array. We talked about a line, and you, in like 8th grade, you learned how to graph a line. And so the idea is that it was a line that it went in one direction, but then it also went in the opposite direction, but it stayed in that direction. That was the idea of the slope. So that was basically a line. It's a set of points in one direction and its opposite. And the last thing to talk about in this unit is something called a plane. And what is a plane? It's basically, I want you to think of it like a flat surface. Whoops. Flat surface, no width, and it goes in, it moves infinitely, in infinite directions. So I want you to think of a plane like the table or the wall. That's a plane. Right. Next thing we talk. Next definition. We might have mentioned something called collinear. We say that points are collinear if points on the same line. And we might say something as the definition coplanar is points or lines on the same plane. So collinear points, that's let's draw a picture here. So here, if we have this line, and here's point, 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 we would say that A, B, and C are collinear. The idea of coplanar is, look at your desk. I'm not asking you to like look at the piece of paper on your desk. You could either, draw a bunch of points on that paper anywhere that would be coplanar, or you could actually draw a bunch of lines on a piece of paper, and you can see those lines are also coplanar. Now, we're really not going to be focused in 3 space, but once again, this is our geometry class. We're starting from scratch and we're defining everything. Okay, the next thing we want to talk about is, let's go back to A, go here. The next thing we want to talk about is naming. So let's think about this. How do we name points? How do we name points? Well, we can see up here I named points by using capital letters. So you'll see like an A, point B, or maybe you'll see point, I don't know, like F, something like that. So we use points to name. We use capital letters to name points. Okay, what about lines? Well, first of all, let me change the color. Display, no. Color, let's go black. So how do we name? So let's think about this. So we have. Well, I'm going to draw a line, and I'm going to put 3 points here. Let's say K, E, N. So the first thing we want to talk about is how we label a label a line. Well, we can use 2 points, right? Any 2 points are fine, but you have to remember the symbol that goes on top. So I would write, like, for example, KE, and I would do this symbol for a line. Another way might be, KN. Put the symbol on top. Okay, that's a line. That's the next thing we spoke about. The next thing we want to know how to label is array. And we spoke in the last class about exactly what array is. It starts with an endpoint and it moves in one direction. So I could say the array KE, I can start my point over K and move in the direction of E. Now we're going to see that's different. That is different than if I wrote EK. This is different. So once again, the first ray starts at K and moves in the direction of E. Ray EK starts at E and moves in the direction of K. Once again, these are opposite rays. What else? What else do we want to name? The last thing we want to, not the last thing, the next thing we want to label is a segment. Come on. Perfect. A segment. How do we label a segment? Well, same idea. KE, but it's beginning, end. I could say, NK, beginning, end. What we can see, though, is KE, this is like a length. So this is kind of equal to EK. It doesn't really matter in this case. That's fine. Okay. The next thing we're going to talk about is a plane. So what I'm going to, for a plane, we use 3 letters. And so what I'm going to do is I'm going to draw a cube, a square. I'm going to label this cube A, B, C, D, E, F, G, and H. And the question is, so I'm going to ask you, how do we name, I might ask you to name the front. And you would say, oh, okay, the front is this face right here. So we would say the front is plane A, B, F. Or I might say plane F, E, A. Please remember that we want to keep the letters in order. We want to move around. How would we label the top? We might say plane EHG. We also might say plane, FGH. Once again, we keep the order as we move around the plane. That's basically it. I might give you a cube, or the homework might give you a cube and say, let me change the color. The homework might give you a cube. Oh, we can move this over, actually. Might give you, say, name some points. And you say, okay, A, B, and G. They might say, name some segments. Any suggestions what a segment? Okay, AB. You might say CG, GC, or maybe EF. Something I want you to think about, what's a diagonal? What segment would represent a diagonal in this cube? So you might say, any suggestions? Good. AC. What's another diagonal? How about HB? This is a diagonal. I want you to come up with a definition. What's a definition for diagonal? Good. The last thing we want to talk about is something called axioms and postulates. And this is going to be really important in our class. So we want to talk about axioms slash postulates. In this class, it's the same. It means the same thing. In more advanced, like logic classes, excuse me, they might mean different things, but we're just going to assume it's the same thing. So assume an axiom or postulate is it's basically an accepted statement of fact. We're just going to, in this class, we're going to be proving a lot of things, but many times we just say, you know what, this is true. Okay, first, let's say our first axiom. Our first axiom is through, let's see, I have it written down nice and neatly. There we go. Through, whoops. Through any 2 points, there is exactly one line. This is an axiom. We accept this as true. We don't have a proof for it. We just accept. Let's think about that for a second. If I draw 2 points here, how many lines can I draw through that? I can only draw one line through those 2 points. Okay. Let's get back to our second axiom. Let's see, number 2. Ready for the next one? If 2 distinct lines intersect, what do you think? What's the result? They meet in exactly 1 point. That's another axiom or postulate. We're accepting that to be true. Let's draw a picture in our notebooks. So let's draw 2 lines here. Let's draw another line. The question is, can these 2 lines meet in another point? Once again, we're only on a piece of paper, because you might say, hey, Mr. Adler, what if I, draw the equator and like lines of longitude? They might meet in 2 places. No. So I'm sorry. In this class, we're on a piece of paper. Can these 2 lines meet in any other place? No. That's another axiom. Let's get back to the third one. Number 3, if 2 distinct planes intersect, what do you think? Well, I want you to think 2 planes. I want you to look at your room right now, and the 2 planes are the wall and the floor. Where do they meet? Well, they meet in a line. They meet at exactly 1 line. Once again, that's another axiom. I'm not going to draw a picture of your wall and your floor. And then the last axiom is, this is kind of cool. Through 3 non-collinear points, there is exactly, what do you think? If I drew 3 points, what do you think? There is exactly 1 plane. And that's how like a three-legged stool works, is that you have the 3 legs and you put it on the floor and it doesn't fall over, because there's only 1 plane that it passes through. So you can have a 3-legged stool, a 4-legged stool, but you can't have a 2. If you have 2, you're going to have a problem. So 3 is the minimum legs you need so that your chair doesn't fall over. That's basically it. You're going to go to your textbook. Let's see if I have the textbook. You're going to go to let's go to the textbook. And you are going to go to page 56 in the PDF, and you're just going to do all the odd problems. The answers are in the back, and I will also want you to do the challenge problems. And that's basically it. So have a good weekend. Let's get back to the stop sharing. See you later.